Hi, welcome back to class. In this class, we'll use this example to further understand how to find vector product of vectors. In case you missed our introductory lessons on vector product of vectors, please do not hesitate to check the description below where you'll find our introductory lesson on vector products of vectors. That said, let's get started. Now, example says A is equals to 2i plus 4j plus 3k and b is equals to I plus 5j minus 2k. Now we'll be using the determinant method so that my cross method A times B will be the same thing as I, J, and K. So that here is 2, 4, 3, 1, 5, and minus 2. Now in using the determinant method, this becomes I into 4, 3, 5, and minus 2. What I've simply done is, one, I've attached signs to it. That's the first thing. Here will be plus, negative. Here will be plus. This is positive. That's why I is positive. Now I've selected items that are not on this row and on this column. This is the row for the column for I. This is the row. Every item 4, 3, 5, and minus 2, they are not on that row. To help you understand determinant of matrices, please do not hesitate to check our description below. We've placed links to that lesson. Now the next is to pick my j, that will be minus j. Then again, I'll be selecting items that are not on that row and on that column. Those items will be 2, here is 3, here is 1, and here is minus 2, and plus k. Then we'll pick the items again. Here is my k, and those items once again will be 2, 4, 1, and 5. Next, now we'll be solving this determinant of 2 by 2 matrices, so that my A times B will be the same thing as I into 2 times minus 2, that's minus 8, minus 15, minus J now into 2 times minus 2, that's minus 4, minus 3, and plus K into 2 times 10, 2 times 5, that's 10, minus 4. So that A times B will be the same thing as minus 8 minus 15, that's minus 23, that's minus 23i, and minus 4 minus 3, that's minus 7, times minus 1 here, that becomes plus 7j, and plus k, that's 10 times 4, that's 6, that's 6k, that's 6k. Now with this, I hope you understand how to treat vector products of vectors.